similar locations are so different is part of what's interesting about the objectives that Dawn wants to understand. And some people like to describe these two bodies as straddling a sort of dew line in the solar system, with Vesta being a little bit closer to the sun and resembling much more the inner rocky bodies of the solar system, one of which is just under our feet, Earth, as well as Mercury, Venus, the Moon, and Mars, whereas Ceres, remaining cool, retaining water, being more like the icy moons of the outer solar system, that is Jupiter and Saturn in particular, have a large retinue of moons that are believed to be similar in structure and composition to Ceres. So let's take a look now at the size of these two bodies. Vesta is almost 600 kilometers, or about 350 miles in diameter. Ceres, the largest asteroid, is nearly 1,000 kilometers, or almost 600 miles in diameter. So these are big bodies. I think most people think of asteroids as sort of little chips of rock, but these aren't. These are pretty big. And to put that in context, this is an image, which I hope you can see, of the largest asteroid which a spacecraft has yet visited. It's called Asteroid Matilda. Excuse me, and as you can see, it's entirely different in scale from something like Vesta and Ceres. And so, as you heard in the introduction, I think of Vesta and Ceres as among the last unexplored worlds in the inner solar system. These are big places. And in fact, they're much more like planetary-sized bodies in context. And to give you something else of a familiar scale, you can see here. But you can see these are large places. It's also interesting to note, I presume most people recall from last summer the controversy which occurred both in the scientific community and in the popular press over the designation of Pluto and its demotion, as some people would say, from being a planet to being a dwarf planet. Well, once it was defined as a dwarf planet, the definition that was applied, it turns out also applies to Ceres. So when Pluto was given this new classification as dwarf planet, Ceres received the same classification. And in fact, Dawn is actually going to be the first mission to a dwarf planet. It's also, I think, interesting to note that I told you a few minutes ago that after Ceres was discovered, or when it was considered a planet for about 50 years. Pluto was discovered in 1930 and was considered by the official astronomical community to be a planet until 2006. And so really they spent comparable amounts of time designated as planets before their classifications were changed. Now, when you look at a picture like this, particularly comparing it with flat California, this is a little bit deceptive because, of course, these bodies are three-dimensional. They're round. And so there's a lot more surface area on Vesta or on Ceres than you might think by comparing it with this flattened view of California. So if we take a more three-dimensional look, this is to scale the continental United States and a map of Ceres. This is color-coded to indicate something about how reflective or how bright the surface is. And the data that we have don't go all the way to the South Pole here at minus 90 degrees or the North Pole at plus 90. But the area inside this white rectangle shows that the surface area of Ceres is actually about 40% of the surface area of the United States. And if you just think about how vast and varied the topography and geology of our country is, there's a lot to see there, and I think there's going to be a lot to see at Ceres. I think it's really going to hold a lot of interesting surprises and a lot of opportunity for great variety. Okay, so, excuse me. Let's just take a little bit more careful look at these two targets. This is Ceres as viewed by the Hubble Space Telescope Advanced Camera for Surveys. Excuse me, showing it rotating, and you can see it certainly looks much like a planet. And on the right here are a couple of different interpretations scientists have of what the interior of Ceres might be like. And you can see there's a large core of rock and ice, and at the top there's ice. But interestingly, somebody's being called, and maybe they want to tell us something about Ceres. But interestingly, in the view on the right, it's possible that Ceres has a subsurface ocean. Actually, liquid water may exist under the ice cap at Ceres. A particularly intriguing possibility. And so one of the things that we want to understand when we go to Ceres is what indeed is the interior like, and is it possible that it has retained water from the time it was formed? This is now Vesta. Here's a view from the Hubble Space Telescope, and this is just a smoothed model, a little bit more pleasant to look at. Here you can see it obviously is not nearly as spherical as Ceres is. This part looks like it is, and you can sort of imagine filling it in to make a nice, more uniform sphere here. But there's something going on here. Excuse me. And what we believe this is an impact crater with a big central peak. Now, many large impact craters in the solar system have a peak like that. The reason is form an impact crater when you have this solar system body and a big meteoroid slams into it, imparts so much energy to it that the surface actually, that the rocks actually melt, and so they slosh away from the impact, and then they slosh back together and freeze. Okay? And so that's why many impact craters have a large peak in them. And this bottom view here is a admittedly crude topographical map of Vesta, where now it's been rotated a little bit, so this peak here is tipped forward toward us a little bit. And the distance, the elevation distance from this central peak to the area down here is more than 10 miles. So 10 miles from the bottom of this crater to the top. And the diameter of this crater is 460 kilometers, or about 300 miles. Excuse me, it's 80% of the diameter of the entire body. And it's so deep that it's believed that it penetrated the crust of Vesta and may expose the mantle, that is the material underneath the crust. And so the opportunity to peek into that crater, besides just thinking about how cool the topography would be and how neat it would be to see this, the opportunity to see into the mantle of a solar system body may be, if not unique, at least very rare. And so I think both Vesta and Ceres hold a lot of opportunity for us to see some really exciting sights. Excuse me. So now that we know where we're going, forgot to include this artist's concept of the formation of this crater. So there's an impact on now Vesta with this large crater here at the South Pole. So now a lot of this material is sprayed out into the solar system, and it's the orbits of these individual bodies are perturbed by planets, and some of it may actually make its way into the inner solar system where you and I live. And in fact, we know, for reasons that I'll tell you in just a second, that this has happened. And so if you've ever been out, looked at the night sky and seen a meteor, you know that's a particle of debris that's come into the atmosphere and burned up, and sometimes that's actually from Vesta. And sometimes that material will make its way down to the surface of the Earth, and in fact, here's a meteorite, which I photographed myself in a museum, that's known to come from Vesta. So maybe you've heard that we have meteorite samples on Earth, a very small number, that are known to come from Mars and the Moon. But about 5%, that's 1 in 20, of the meteorites that have been found on Earth are known to come from, or believed to come from Vesta. So the Moon, Mars, and Vesta are the only solar system bodies to which we've actually linked specific meteorites, and more of them have been linked to Vesta than to any other place. And so we've got a lot of samples of Vesta here on Earth, or at least that's what we believe to be the case. So now we'd like to, having studied those, go to Vesta and look at the material in its geological context to understand still more about how this picture fits together and what it tells us about the origin of the solar system. So here's the itinerary. We're going to depart most people's favorite planet this summer in June or July. And